Okay, area in calculus using definite integrals. And the directions say accept the definite integral that will determine the area of the given region. Do not evaluate. So we're looking at problem 1, A and B. And the function A is g of x equals 3 minus 3x. Right? And an integral, which uses that S symbol, is used to determine the area between the curve and, in this case, the x-axis. Well, you can tell here, you got to pay attention to the labels, it goes from 0 to 1. So I'm going to set my integral from 0 to 1. And that's of the function 3 minus 3x. And while not strictly necessary in writing, your calculator would make you put a parentheses around that, most books will do that, dx. And that integral will give you the area between the curve and the x-axis from 0 to 1, since it's a function x. So I'm looking at problem B. And this one goes from -2 to 4. Least to greatest, left to right. And the function is just 2 dx. And that dx is crucial because it tells you the antiderivative with respect to the variable x. So let's look at another problem. Alright, problem 2. Now these are functions in y. And you can see here that the curve is between the function f of y equals y squared, or the area is between f of y equals y squared and the y-axis. And this goes from 0 to 2 in the y-axis. So I'm going to set my integral and go from 0 to 2 in the y-axis. The function in terms of y is y squared, and it's dy, because the function is respect to the variable y. Let's look at problem B. This goes from -2 to 2, again the y direction, and the function is absolute value of y, dy. And that will give you the area between the curve absolute value of y and the y-axis. This is a function y. And let's look at another problem. So again, we're finding the area and we're not evaluating. So this one looks like it goes in the x-axis. It's a function with respect to x from -1 to 3. And you must be careful about your labels on your axes. So I'm going to set this integral up. It goes from -1 to 3 of 2 to the x power dx. And that integral will give you the area between that curve and the x-axis. Now, this one is a function in theta. And this would be the theta axis, and this would be f of theta, right? So it goes from pi over 2 to 3 pi over 2. So those are my limits of integration. And the function is cosine of theta. Put a parentheses around that. D theta. And that integral will give you the area between the curve and the theta axis. Now, I want you to notice something, that this area, this would be a negative area, which is something we're going to talk about later, because it's below the x-axis. And then my last slide just talks about definite integrals. And the definite integral is from a to b of f of x dx. And below I have something called a Riemann sum, which is basically the limit definition of an integral.